Welcome to our channel. Let's begin the journey.
You know, when we think about monumental discoveries in astrophysics, we usually picture massive, billion-dollar telescopes, right? Well, today, we're looking at how the entire landscape of the cosmos was completely rewritten by a 19-year-old armed with nothing but a scratch pad. The human journey to understand the universe relies so heavily on complex equations, and as we'll explore today, math possesses this really profound beauty when it comes to predicting the ultimate fate of the stars.
So, let's just dive right into the central cosmic mystery we're unraveling today. We all know stars are basically these giant nuclear reactors. They forge elements and release colossal amounts of energy. But that leads us to a much darker, honestly more profound question. What exactly happens when that immense reactor finally runs out of fuel? Like, how does a star actually die?
Back in the 1930s, the scientific consensus held pretty tightly to a comforting myth. The top minds believed that every single star, after exhausting all its fuel, would just quietly contract into a gentle, highly dense white dwarf and gradually cool down over eons. Kind of peaceful, right? But the mathematical reality we're unpacking today revealed a literal deadly limit. It showed that massive stars inevitably collapse into far, far more bizarre and devastating forms.
To really understand how this peaceful consensus was completely shattered, we have to trace the physical and mental journey of a young guy named Subrahmanyan Chandrasekhar. Picture this, it's 1930. He's on a long ship journey, sailing from India over to England to continue his studies, and he's just 19 years old. During those quiet, endless weeks at sea, while the rest of the world was totally oblivious, he was quietly performing a series of profound mathematical calculations on a scratch pad. By the time his ship actually docked in England, he literally held the math that would change cosmology forever right there in his hands.
So how exactly does a teenager upend the entire scientific establishment? Well, he did it by brilliantly mashing up two highly distinct fields of physics. He took the incredibly complex, super weird rules of the microscopic world, quantum mechanics, and he merged them with Albert Einstein's physics of the very fast and massive special relativity. It was this incredibly bold, totally unique fusion of ideas that allowed Chandrasekhar to find this inescapable mathematical limit hidden deep inside dying stars.
Now you might be wondering, when a star dies and turns into a white dwarf, what's actually stopping it from just collapsing in on itself completely? Chandrasekhar proved its stability is maintained by something called the degeneracy pressure of electrons. Don't let the name intimidate you. It's basically a delicate, microscopic quantum defense mechanism. Think of it as the star's absolute last shield, actively pushing back against the crushing weight of its own gravity. But here's the catch. The crucial tipping point boils down to one highly specific number, 1.4 times the mass of our own sun. Chandrasekhar discovered that this delicate quantum pressure we just talked about, it isn't infinitely strong. There is a very real breaking point. This precise measurement, which we now universally call the Chandrasekhar limit, is the definitive boundary. It dictates a star's final physical form. It's literally the exact threshold between stability and absolute destruction. Because if the dead remnant of a star has a mass that crosses that 1.4 limit, the microscopic quantum pressure of those electrons completely fails. It is totally overwhelmed. The crushing force of gravity becomes so unbelievably dominant that there is absolutely no natural force left in existence strong enough to resist it. And this dynamic creates what is basically an inevitable, terrifying pipeline of stellar death. It's a strict mathematical sequence. First, the colossal nuclear reactor runs out of fuel. Then, if that remaining core is heavier than 1.4 solar masses, boom, we hit the danger zone. The degeneracy pressure collapses entirely, and crushing gravity takes over the wheel, pulling all matter inward with unimaginably violent force.
Now, you'd probably assume the scientific community immediately celebrated this profound breakthrough, right? Well, the harsh reality of scientific progress is often quite different. When Chandrasekhar presented this incredible discovery, it was met with fierce opposition from the more conservative scientists of the era. They firmly rejected his limit. To them, the idea that a star could just endlessly collapse was simply an unacceptable conclusion. It completely shattered their neat, comforting view of a static, gentle universe. But hey, math doesn't really care about our comfort. Despite the intense resistance, Chandrasekhar's calculations firmly established an immutable cosmic rule. The universe simply does not allow matter to exist as a white dwarf if it's too heavy. It must inevitably collapse. And by proving this, Chandrasekhar violently threw open the door to much more bizarre forms of matter. His limit directly paved the crucial way for the scientific acceptance of incredibly dense objects like neutron stars, and ultimately, it laid the very foundation for the existence of black holes.
And this naturally connects his tipping point to the mathematical endpoints predicted by other brilliant minds. Once Chandrasekhar proved a star could collapse past that white dwarf stage, it completely validated the theoretical nightmares of scientists like J. Robert Oppenheimer and Carl Schwarzschild. Oppenheimer calculated that this core would just continuously compress down to infinite density, literally piercing the fabric of space-time itself and creating gravity so incredibly strong it outright forbids light from escaping. Meanwhile, Schwarzschild's equations show the surrounding space-time bending so drastically that it inescapably closes in on itself. These were the monsters waiting at the end of the collapse.
Think about it. Decades before our technology could ever dream of photographing a black hole, these incredible minds mapped out the dark anomalies of the universe. A 19-year-old on a ship mathematically forced humanity to accept that there are regions of space aggressively collapsing into blind spots that devour light entirely. It's just a breathtaking testament to the sheer force of human intellect.
Which brings us to our final thought for this explainer. As scientists have continued to look deeper, they've found the universe is far stranger than anything beyond normal human imagination. If a teenager's mathematical equations could predict the reality of black holes hiding in the dark, long before we could actually see them, we have to ask ourselves, what other invisible, overwhelming forces are silently shaping our universe right now, just waiting for the right mind to decode them?
The view from here is breathtaking. Command, we are in position and ready for the next phase. If you liked the video, subscribe and comment the topic you want next. Thanks for watching, and stay unstoppable.